Hi everyone. In part 3 of this video on looking up critical values or percentage points from the standard normal table, I'll be showing you how to find those when we are using the table that gives you of the form probability that z is between 0 and a. Okay, first question, find a, so that probability of z less than a is equal to 0.975. First, to solve it, let's sketch a standard normal. So we know here that z runs along here. We know that the standard normal is centered around 0. We know that the area under the curve is 1. And since it's balanced around 0, we know that the area to the left of 0 is going to be a half. Area to the right of 0 is going to be a half. Or if you wish to talk in percentage terms, 50% of the area below, 50% of the area above. That matters because look, after the equality sign, we're given the probability, always. This probability here, 0.975, is bigger than half, isn't it? So that tells us the point A we're after must be to the right of 0, not to the left. Alright? And since the area is almost got all the area in there, it must be quite far to the right, so it's about here, say. And this shaded region will be 97.975 or 97.5%. It's important that we get the right point along this line, because if it's to the left of 0, we'd after a negative value. Okay. Now I'm going to show you how to find this percentage point when we're using the table where z is between 0 and a. Well, we have to convert this into the form such that we can use that table. That table gives us from the point A, oops, that's not a good line, from the point A, which is the same A here, to 0. Okay, so we're after this one. Well, if the area comes to 0.75, we know that everything in red here is going to be 0.5. Therefore, everything here, which we're after, is going to be 0.975 minus 0.5, isn't it? And that gives me, let's do this in a different color, 0.475. In other words, we have to look up 0.475. This problem here may be expressed therefore as giving me the same a as if we solve this problem. Z between 0 and a is equal to 0.475, equivalent in terms of looking for a. So let's turn to the table. Table is from statisticsmentor.com. So the percentage points, critical values, is given by the numbers in bold here, running along here. That gives me the critical values up to the first decimal place, and along here gives me to the second decimal place. Okay, notice as I'm sliding along from left, everything in the body here represents probabilities to the right of a point A. And as I'm sliding along here, you can see probabilities are increasing. We want 0.475, so we can go down quite quickly here. Okay, 0.47, we're getting close. 0.475. Aha, we've got it exactly, it's here. 0.475. So up to the first decimal point for this percentage point, we look here, it's 1.9. To get the second decimal point, we go up the column, it's 0.06. Take it together, 1.9 plus 0.06, answer is 1.96. So from the table, 1.96, done. Okay, next, the probability that z is less than a equal 0.025 after a. Draw the distribution centered around 0. This time probability is small, it's less than a half, so it must be to the left of 0. something like this here. And let's just say it's just write a minus in front of the A to show it's actually a minus figure. This shaded region then is 0.025. Right. I've got to convert this so that it's equivalent problem, so that z is between 0 to a value a. Well, if we look at it, first of all, that's a negative sign, so we want to convert to an equivalent problem but with a positive a, because the table only gives us values for positive values of the percentage point. If we flip it over, can you see it's the same thing there? This being 0.025, and that's a positive value of a. Well, if that's 0.025, it must mean the area between 0 and a, which is what our table gives us, must be 0.475, because together they'll add up to 0.5. In other words, the question that I'm being asked, I can also find a by looking up in the table this 475 and then changing the sign because it's a negative value. Well, we have already just solved this in the first part of the question. That was our first question. That came to 1.96, but we're after the negative value, so negative a is minus 1.96. And that gives us this figure. Finally, we're after the points minus a and plus a, so that z between minus a and plus a is equal to 0.9. Okay. By symmetry, those numbers must be same distance from 0, because they're just the same numbers but different signs. And the area between them must be 0.9, i.e. 90%. Alright, that's what we're after. Again, we have to convert this into a problem where we can use the table, so z must be between 0 and a number. Right, well look, we only have to find one of the values of a minus a, because we know that one is just minus the other one. Since the table only gives us positive values for a, we'll take this one. Like that. Okay. Now, what does it mean to say that's 90% or 0.9 between minus a and a? What's left? Well, shade in the tail here and shade in red must add up to 0.1, i.e. 10%. And since this is symmetrical, must be equal area in the shaded region in red. So it must come to 5% or 0.05. If we translate that over here, that must be 0.05. If that's the case, what is the area for between 0 and a? What is that area there? Well, it must be 0.45, because then it'll add up to 0.5. In other words, to get the value of a, we look up in the table to find this 0.45. Right, so 0.45, let's have a look. Right, 1.5, we've got 0.433, gets smaller. Sorry, it's starting to increase. There we are, 0.45. Aha, here you go. We notice we don't get to 0.45 exactly. It's between these two numbers here, right? So it's between. We've got 0.4495 and 0.4505. So the answer is between there somewhere. Now 0.4495, the percentage point for that is 1.64, and for the other one it'll be 1.65. Let's write that down. Okay, so here I've written it down. Our answer we're after is 0.45. It's between here, so we can say also that answer is between for A is between 1.64 and 1.65. Now the final answer that we would write down really depends on what you've been taught at college, because what we've got here, we haven't got an exact answer, so basically we're resorting to a guess. Okay. Now some teachers might just tell you round down. So you just say 1.64. You could round up. You could say the answer is 1.65. you could present them both and say the answer is between 1.64 1.65. You could also note here that the answer 0.4495 is below 0.45 by 0.0005, and 0.4505 is higher than 0.45 by 0.0005. In other words, they're both about same distance away from 0.045. Because of that, because of the same distance, you could just say, let's take the average of 0.64, 1.64 and 1.65, and so we write down the answer as 1.645. I tell my students not to bother, don't concern too much about the interpolation business, because remember, the stats tables were invented in the days, more useful in the days when the computing power was poor, but nowadays with our computing power, our computers will tell us to a very exact figure what our value of A would be for this problem. And since statisticians don't use stats tables really, they use computers, this is not an issue for us really. Okay, and we'll just note that if we use the first method, round down, we'll get 1.64. If we round it up, it's 1.65. If we use some kind of interpolation method, we get an answer between 1.64 and 1.65. At the end of the day, we are only differ to 0. by 0.01, don't we? And what is 0.01 between friends? Or in your case, between you and your lecturer. Okay, I'm Phil from Statistics Mentor.